Amines are a unique class of compounds that contain a nitrogen atom bonded to one or more organic groups. Examples of commonly known amines include amphetamine and methamphetamine. Amphetamine is used to treat ADHD and obesity, while methamphetamine is a common illegal recreational psychostimulant. Amines can be classified based on how many organic parts, called R groups, that are bound to the nitrogen atom. In primary amines, a nitrogen with a lone pair is bonded to one R group and two hydrogen atoms. In secondary amines, a nitrogen with a lone pair is bonded to two R groups and one hydrogen atom. In tertiary amines, a nitrogen with a lone pair is bonded to three R groups but no hydrogen atoms. Now we are going to take a look at how to name amines. The first step is to find and name the parent chain. The parent chain is the longest continuous chain of carbon atoms that contains the point of attachment to the nitrogen. For amines with more than two carbons, the position of the attachment to the nitrogen must be indicated by adding a number before the parent chain. Assign position numbers to the carbons in the parent chain. Position number 1 is assigned to the carbon at the end of the parent chain that is nearest to the point of attachment to the nitrogen. Count the carbon atoms in the parent chain, starting with the alkane name that corresponds to the number of carbon atoms in the parent chain. Replace the E at the end of the alkane name with amine. In this example, the parent chain of this amine contains 7 carbons and the nitrogen is attached to the third carbon, so it would be called 3-heptanamine. The second step is to name any alkyl group substituents. Alkyl group substituents that are attached to the parent chain are named in the same way as you did for alkanes. For secondary and tertiary amines, the non-parent chain R groups attached to the nitrogen are named as substituents. N- is written in front of the R group substituent name instead of a position number in order to indicate that the R group is attached to the nitrogen. In this example, there is only one substituent and is attached to the nitrogen, so we would call it N-ethyl. The final step is to construct the name of the amine by placing the alkyl groups in alphabetical order and specifying their position, followed by the name of the parent chain. This is done the same way as you did for hydrocarbons and carboxylic acids. Remember to use a dash between position numbers, or N, and letters. The final name for this example is N-ethyl-3-heptanamine. In our next example, we're going to look at naming a tertiary amine. The longest carbon chain in this case is the one to the right of the nitrogen. We will number the chain from left to right to give us the lowest number for nitrogen's attachment. The parent chain has 4 carbons. Nitrogen is attached to the first carbon, so the name is 1-butanamine. The 2 substituents bound to the nitrogen are ethyl and methyl. List them in alphabetical order and indicate their position by putting an N in front of the group. The final name for this molecule should be N-ethyl-N-methyl-1-butanamine. Now it's your turn to practice identifying and naming an amine. Indicate which of the following choices is an amine, what type of an amine it is, and then name it. Click pause and work on the problem. Hopefully, you can see that the correct choice is B because it's the only one with a nitrogen group. Looking at B, we can classify it as a tertiary amine because it has 3 organic groups bound to the nitrogen but no hydrogen atoms. The longest carbon chain is to the right of the nitrogen, and we will number it from left to right to demonstrate nitrogen's position as attached to carbon number 1. The parent chain consists of 3 carbons, so it is called 1-propanamine. The substituents bound to nitrogen are 2 methyl groups. Since there are 2 methyl groups, we will add a di prefix in front of methyl. Indicate the position of the substituents by putting an N dash in front of their name. Your final answer should be N, N dash dimethyl dash 1 dash propanamine.